In the natural sciences, we deal with quantities such as mass, volume, and length. These quantities are often the result of a measurement. The result of a measurement is expressed in a number and a unit. And in this segment, we will focus on the unit. We'll focus on those units that are important in chemistry. Units are measures of quantities. Units are relative measures. They're chosen, and once they are chosen, we try to apply them consistently to establish a convention. The convention in the sciences is called the International System of Units, or SI for short. In the SI system, the unit for length is the meter. The abbreviation is M. The unit for mass is a kilogram, abbreviation kg. The unit for time is the second in the SI system, and the abbreviation is the letter S. The unit for temperature in the SI system is Kelvin, with a capital K as the abbreviation. And finally, the amount of substance, a very important quantity in chemistry, has the unit mole in the SI system, or MOL for short. Now in this segment, we will focus on the first four quantities, and we will leave the mole, the amount of substance, for a later segment. So let's start with the quantity of length. The unit of length in the SI system is the meter. Now the meter is very precisely defined. It is defined as the distance traveled by light during a time interval of 299 millionth of a second. It's a very precise definition. However, this definition is not very useful. Yet, it is important to have an intuitive understanding of how long a meter approximately is. So, instead of this definition, I give you another definition. This is my daughter Selah. She's 4 years old, and she is approximately 1 meter tall. A much less precise definition, but practically very useful. Let's move on to mass. In the SI system, the unit for mass is the kilogram. The kilogram is a relative measure. It is defined as the mass of a prototype mass. And that is a block of metal which is kept in Paris under extremely secure conditions. These conditions are very secure, otherwise the mass would change and hence our unit would change as well. However, in chemistry, we make use of the unit grams more often than kilograms. The unit of gram is practically more useful. 1 kilogram equals 1,000 grams, or 10 to the third grams. Vice versa, 1 gram equals 0.001 kilograms, or 10 to the minus 3 kilograms. How much is a gram approximately? Well, a gram is approximately the mass of the contents of this sugar pouch. The next quantity is time. In the SI system, the unit for time is the second. The second also has a very precise definition. It is related to the radiation that comes off cesium atoms. 9.19 billion oscillations of this radiation corresponds to the duration of a second. Now once again, a very precise definition, not very useful for daily use. Fortunately, I think we all know approximately how long a second lasts. Let's move on to temperature. There are several temperature scales that you may have heard of. Now it's useful to compare these temperature scales relative to two temperature points. These temperature points are the boiling point of water and the freezing point of water. Let's look at the Fahrenheit scale, a scale you are probably very familiar with. On the Fahrenheit scale, the boiling point of water is 212 degrees Fahrenheit. The freezing point of water is 32 degrees Fahrenheit. In between these two reference points are 180 units of Fahrenheit. Now, even though Fahrenheit is the most commonly used scale in the United States, it is scientifically not frequently used. Celsius is another temperature scale. The boiling point of water is 100 degrees Celsius, and the freezing point of water is 0 degrees Celsius. In between these two reference points are 100 units of Celsius. The Celsius scale is more frequently used in the sciences compared to the Fahrenheit scale. However, the Celsius scale is not the SI unit for temperature. The SI unit for temperature is Kelvin. The Kelvin scale is related to the Celsius scale, in that the boiling point of water and the freezing point of water are separated by 100 units. However, the unit of Kelvin has a value which is 273 more than the value of Celsius. The Kelvin scale relates to the absolute zero temperature. The absolute zero temperature is exactly 0 Kelvin. Now, it's very useful to relate these temperature scales and to be able to make conversions between them. If you want to make a conversion from Fahrenheit to Celsius, you take your temperature in Fahrenheit and subtract 32 units of Fahrenheit. Then you multiply that by 5 and divide by 9. Vice versa, if you would like to convert from Celsius to Fahrenheit, you take your temperature in Celsius, multiply by 9, divide by 5, and then add 32 units of Fahrenheit. And finally, converting from Celsius to Kelvin involves starting with your temperature expressed in Celsius and add 273.15 units of Kelvin. Now let's finish this segment with a short exercise. Let's convert 98.6 degrees Fahrenheit, which is about the temperature of your body, from Fahrenheit into Celsius. We take our temperature in Fahrenheit, subtract 32 units of Fahrenheit, then multiply by 5 and divide by 9. We find 37.0 degrees Celsius.